In section 2.2, we're going to look a little bit more in depth at experimental designs versus sampling designs. And in this section, we're going to talk about some of the characteristics of experiments a little more than we did last section, some of the considerations that come into play. But in particular, one thing that we're really going to look at that will come up over and over again in this course is this notion of randomization. Our goal in statistics is to take results from a sample and generalize them to the population as a whole. And in order to do this, we need to have representative samples of the population. And initially, you may think that the way to do that would be to try to really select your sample to be truly representative of the population. So for instance, if we're studying adults in the United States, you might think, oh, well, we should have half men and half women. We should have some sort of racial diversity and other sorts of considerations that make this sample representative of the population. It turns out that's not really a good approach. The better approach is to make your sample entirely random. And you might think, well, this is going to result in potentially a sample that's not really representative of the population. And that's true. However, your average sample will be representative of the population. And we can use math, because we've selected this totally randomly, to understand kind of how far off our results might tend to be from the true results for the population. And in particular, in the context of this section, randomization shows up in two very different ways depending on whether we're doing an experiment or whether we're doing an observational study. So I'll start actually with an observational study, which is kind of backwards of how the section does it. But in an observational study, randomization is introduced by means of a sample. The randomization is from the sample. And there, in this section, you'll see there are various ways of obtaining a random sample, and saying, oh, let's just get a random sample is a lot easier said than done often. There can be lots of practical issues with truly getting a random sample. But the idea is that if your sample is randomly selected from the population, then we can use math to figure out how far off it should tend, the values that we calculate should tend to be from the true values for the population. So the sample is where we get the randomization. In an experiment, and there are various kind of types of experiments, situations with experiments, but I like to think of experiments, as an example, just some medical experiment where we're giving people a drug for something. You realize that trying to get a random sample would be totally impractical. If you just got a random list of people and contacted them and asked them if they wanted to be involved in some medical trial, almost all of them would say no. And we would suffer from some serious non-response bias. So in an experiment, generally speaking, the sample that you're using is not at all random. In fact, the sample usually consists of volunteers in some sense. And so if your sample consists of volunteers, then you can't expect that your sample is at all representative of the population. And so you have to introduce randomization in a different way. And fortunately, we can do this because in an experiment, the fundamental distinction between an experiment and an observational study is that the researchers get to control one or more variables. They control some explanatory variables. And so the way that randomization shows up is by randomly assigning treatments. So in this section, you'll see a lot more than just randomization, right? There will be a lot of in-depth look into how we design experiments and how we sample populations. But I want you to have this idea in the back of your mind that you should be looking at this important distinction in how randomization comes into play. In an observational study, the sample is what's random. In an experiment, the sample is almost certainly not random, and the randomization is coming from the random assignment of treatment.